Hello Math 3A and welcome to some examples for problem set number 5. My name is Greg Perkins. Thanks for joining me. So there's these two runners. They start at the same point, so that's going to be the starting point. And then one runs north. So here's the person that's running north at 10 miles an hour. So on this, I can't write the 10 because that's its derivative, since that's a rate. And what I need to do is put a variable like y, and then y is going to be in miles. How many miles did this person run? And then another person starts running west. I guess these two people didn't like each other. They didn't want to go running together. So the X person isn't quite as fast. Oh, maybe that's why they weren't running together, because they weren't the same rate. Anyway, so this person is running west, and X is how many miles that person has run. And then how fast is the distance between them? So this person would be up here, the other person would be here, so the distance between them is this, which I'm going to call S, the distance between them. So this is saying take the derivative of S. So the question is asking for the derivative of S. Well, since the north and the west line are perpendicular to each other, I have a little right triangle. So I can do the Pythagorean Theorem. So S squared is equal to x squared plus y squared. And since we're supposed to find the derivative, I'll go ahead and take the derivative. On the left side, first use the power rule, so that's going to be 2 times s. And then you have to take the derivative of the s. So you can either call that ds dt, or you can call it s prime for short. So I'm going to call it s prime for short. It saves some ink. With the price of ink these days, I got to save every little bit that I can. And then on the right side, take the derivative. So that's going to be 2x. And then the derivative of x, and you could either write dx dt right here, or x prime. Either way you do it, that means how fast is this person running. So that's the west person. So this 8 right here is actually the x prime. And then continue on, take the derivative of y squared, which is going to be 2y, y prime, and then the y prime is the 10 miles an hour. So we're trying to solve for s prime, and I do know the number for this is 8, and I do know the number for this is 10, but I don't know any other numbers. Well, that's where the 90 minutes is used. And I did this on purpose. The units are not matching because this is in hours and this is in hours, so I need to change this to hours. Well, 90 minutes is an hour and a half, or in other words, 1.5 hours. So I need to use this information to find out, well, what does x equal, what does y equal, and what does s equal? So this part over here is going to be my calculus part, and I'm going to just leave this alone for a moment, and I'm going to move over here and do algebra. And once I finish with the algebra, I'll have the s and the x and the y, and I can plug those in. All right, if this person is running at 10 miles an hour, and they do that for an hour and a half, well, the first hour they would run 10 miles, the next half hour they would run 5 miles, or in other words, if you just multiply these two, that's going to be 15 miles. And that's the person going north, so I'm basing this on t equals 1.5. The person going north is y, and then that would be 1.5 times 10 is 15 miles. And then for the person that's running west, so if you multiply this by 1.5 hours, that would be 8 for the first hour and 4 for the next half hour, so that's going to be 12 miles. Nice little warm-up. And then once again, I could use the Pythagorean Theorem, so s squared equals 12 squared plus 15 squared. And then what does that equal? So 12 squared plus 15 squared. 12 squared plus 15 squared is a 369. And then that's what s squared equals. So I still need to take the square root of 369. And it's a 19.209. So s is equal to a 19.209. So the distance between them would be 19.209 miles after an hour and a half. But the question is asking how fast is this line or this distance growing? When I look over here, hey, why is it blurry? Sorry about that. I have to tell it to focus on my hand, otherwise it gets blurry. Sorry. Okay, so this has a 2, and this has a 2, and this has a 2. So I could actually divide by 2, and it will cancel all of those 2's. Now in place of this s, that's the 19.209, and then times s prime. And then the x, that was this 12. And the x prime is 8 miles an hour. Plus the y is 15. And the y prime is 10. So then this is going to be, let's see, 12 times 8 is 96. 15 times 10 is 150. And then to solve for s prime, just divide both sides by 19.209. So there's a 96 plus a 150, and then divided by 19.209. So s prime is 12.806, and then that would be in miles per hour. So this distance is growing by 12.806 miles per hour. All right, that one's done. On problem set number 5, the first page is all about right triangles, so hopefully this will definitely help you out with the first page. Now let's look at the next page, and this data comes from real life. So as you know, at the end of 2021, there was an exponential surge in new COVID cases. So I went and looked it up. December 1st of 2021, there was 139,320 new cases per day. That means on December 1st, a new 139,320 people tested positive for COVID. Go 1 month later, January 1st, the beginning of 2022, it had grown to 286,637 new cases per day. So basically, if you go to December 1st, that number right there represents 139,320, and then it's growing exponentially, so it's going like that, which means I'm going to be using the Pert formula. Also, that word right there is telling me use the Pert formula. So with the Pert formula, I do not have the R. There is nowhere in here that it says, oh, it's growing at 3% or something like that. So I need to find the R first. In order to do that, this is the beginning, 139,320. And then it goes E to the R, and then T. Well, here's another case where you have to pay attention to the units. This is per day, and this is per day, which means T needs to be days. So even though this is 1 month later, I can't use 1 month because I'm supposed to be using days. Well, from December 1st, December has 31 days. So from here to here, that's actually 31 days. And then after those 31 days, the amount of new COVID patients or new people with COVID was 286,637. All right, now I need to solve for R. So the first thing to do is divide both sides by this 139,320. 139, 320. So the left side will just be that fraction. Just recopy that part for now. And then it equals e to the r times 31. Next, to eliminate this e, use natural log. So take natural log of both sides. These two are going to cancel each other out. So on the right side, it just leaves r times 31. And then the left side has natural log of that fraction. And finally, to solve for r, all I need to do is divide both sides by 31. Okay, so that is the natural log of a 286,637, which was divided by a 139,320. And then that's divided by 31 days. So the decimal is 0.023. So R is a 0.023, which basically means that it was growing at 2.3% per day. That is pretty fast. Now finally for this, it said find the formula for AT. So that basically means go back over here and replace this with the decimal 0.023 that we just got. And then this will just stand for T days. So the formula is 139, 320, e to the 0.023 t. And there, part A is done. Now for part B, do some calculus with that. So for part B, find the derivative. So first I'm going to need to write down the function that I got my answer from part A. Okay, now I'm done with that. So find the derivative of this function, then plug in a 46, and then explain what it means. Explain its meaning. Okay, since this is the e function, the derivative is going to be the same thing. So the derivative of the e function is the e function. It's actually the only function that does that. But then there would also be the chain rule. You still need to take the derivative of this. Well, the derivative of t would be 1, so that means that we're multiplying with this decimal, 0.023. Okay, there's the derivative. Now plug in a 46. So a prime at 46 equals the same thing, and then e to the 0.023 times 46, and then multiply that with the decimal, 0.023. And then use a calculator. So there's a 139,320 second e to the 0.023 times 46. And then move out of the exponent and move down and multiply by the decimal 0.023. So it equals 9,230. And to be technically correct, I'll even put the decimal. So that's what, hold on, I have to focus on my hand. There we go. So that's what a prime of 46 is. Well, derivative means how fast something is changing. And the 46 means 46 days later. The whole story started at December 1st. And since December has 31 days, If you take 46 days and subtract December, then that's going to leave 15 extra days. So that means that this is the 15th of January. So January 15th, and that's 2022. The COVID rate was, and since this is a positive, that means it's growing, getting bigger. And that would be an extra 9,230.492 people per day. So you might look at that and think, what, that's only 9,000 people getting COVID. That's not very much. No. What that's saying is on January 1st, there was a brand new 286,637 people just that day that got COVID. So the next day, it's not going to be another 286. It's going to be a 286 plus another 9,000 people. So now we're into like the 295 region. And then the next day, another 9,000 people. And by the time you get to January 15th, then it would be close to 300,000, but then there would be even an extra 9,230 compared to the day before. Okay, so that's it. I hope you'd enjoyed it as much as I did.